The Earth's surface is a place of incredible diversity, from towering mountain ranges that scrape the sky to vast, arid deserts that stretch endlessly towards the horizon. These landscapes are awe-inspiring, but they are just the beginning of our planet's wonders. Beneath the waves, hidden from our everyday view, lies a world just as varied and awe-inspiring. Among these underwater wonders, the Mariana Trench stands alone in its grandeur and mystery. Imagine a scar upon the Earth's crust, a crescent-shaped trench plunging deeper than any other known point on the planet. This is the Mariana Trench, a place where the ocean floor drops to unimaginable depths. Located in the western Pacific Ocean, east of the Philippines, the trench stretches for over 1,500 miles. It is a vast underwater canyon that has fascinated scientists and explorers for decades. Its deepest point, known as the Challenger Deep, lies approximately 7 miles beneath the surface. This depth is so extreme that the pressure is over 1,000 times greater than at sea level, creating an environment that is both hostile and intriguing. To put that in perspective, if Mount Everest, the tallest mountain on Earth, were placed at the bottom of the trench, its peak would still be submerged by over a mile of water. This comparison helps us grasp the sheer scale of the Mariana Trench. The Mariana Trench represents the ultimate frontier of exploration, a place where darkness reigns supreme and life takes on strange and wonderful forms. In this pitch-black environment, bioluminescent creatures create their own light, and deep-sea exploration vehicles navigate the crushing depths to uncover new species and geological formations. For centuries, the ocean's depths remained an enigma, a realm of myth and speculation. Ancient civilizations spoke of sea monsters and underwater realms, but it wasn't until the advent of modern technology that we began to truly understand what lies beneath the waves. It wasn't until the late 19th century that humans began to develop the technology necessary to plumb the abyss and uncover the secrets of the Mariana Trench. Early expeditions used rudimentary equipment, but they paved the way for the sophisticated submersibles and remote-operated vehicles we use today. What they found was a world unlike anything they could have imagined. Strange and resilient creatures, adapted to the extreme conditions, thrive in this dark, high-pressure environment. Each discovery in the Mariana Trench reveals more about the resilience of life and the mysteries of our planet's final frontier. The year was 1875. The HMS Challenger, a British Royal Navy ship, embarked on a groundbreaking scientific expedition. Equipped with state-of-the-art sounding equipment, the Challenger's mission was to map the ocean floor and investigate the deep sea. Little did they know they were about to stumble upon one of the planet's most remarkable geological features. As the Challenger traversed the Pacific, its crew systematically lowered weighted ropes to measure the ocean's depth. Near the Mariana Islands, their readings plummeted dramatically. They had discovered the Mariana Trench. It was a monumental moment in the history of ocean exploration, marking the first time humans had glimpsed the immense depths of this underwater canyon. The discovery of the Mariana Trench sparked intense curiosity within the scientific community. What mysteries lay hidden within its depths? What strange creatures might inhabit this alien world? It was a time of great excitement and anticipation, as explorers and scientists alike prepared to venture further into the abyss. Decades passed before humans could attempt to reach the bottom of the Mariana Trench. The technology required to withstand the immense pressure of 7 miles of water overhead simply did not exist. But the allure of the trench remained strong, and the dream of reaching its depths continued to inspire engineers and adventurers. Finally, in 1960, that dream became a reality. Swiss oceanographer Jacques Piccard and U.S. Navy Lieutenant Don Walsh climbed aboard the bathyscaphe Trieste. This specially designed submersible, resembling a large underwater balloon, was built to withstand the crushing pressure of the trench. On January 23, 1960, Piccard and Walsh began their historic descent. The journey to the bottom of the Challenger Deep took nearly 5 hours. Peering out of their tiny porthole, Piccard and Walsh witnessed a world of perpetual darkness, illuminated only by the lights of the Trieste. They observed signs of life even at this extreme depth, proving that the trench was not a barren wasteland, but a unique and thriving ecosystem. Section 4, Challenger Deep, plumbing the depths of our planet. The Challenger Deep, named after the HMS Challenger, represents the most extreme environment on our planet. This abyssal zone is located in the Mariana Trench, the deepest part of the world's oceans. The HMS Challenger expedition of the 1870s was the first to sound the depths of this trench, giving us a glimpse into the mysteries that lie beneath. Here, at the very bottom of the Mariana Trench, the pressure is over 1,000 times that at sea level, equivalent to having the weight of 50 jumbo jets pressing down on every square inch. This immense pressure creates an environment that is both hostile and fascinating, pushing the limits of what life can endure. The water temperature hovers just above freezing, and the darkness is absolute. Sunlight never reaches these depths, creating a world that is perpetually shrouded in darkness. The cold, dark waters are a stark contrast to the vibrant, sunlit surface of the ocean. Despite these harsh conditions, life persists. The creatures that inhabit the Challenger Deep have evolved unique adaptations to survive. These adaptations include bioluminescence, which allows them to create their own light, and specialized body structures that can withstand the crushing pressure. Over the years, remotely operated vehicles, or ROVs, have explored the Challenger Deep, capturing footage of bizarre and fascinating creatures. These ROVs are equipped with advanced technology that allows them to navigate the extreme conditions and bring back valuable data and images. These include giant single-celled organisms called xenophyophores, ghostly white amphipods, and translucent sea cucumbers. Each of these creatures has adapted in extraordinary ways to thrive in an environment that would be inhospitable to most forms of life. These creatures have adapted to survive in an environment of perpetual darkness, crushing pressure, and scarce food sources. Their existence challenges our understanding of the limits of life and showcases the incredible diversity of life on our planet. The Challenger Deep is not only a haven for unique life forms but also a window into the Earth's geological history. The sediments and rocks found here provide clues about the processes that have shaped our planet over millions of years. The rocks and sediments found at these depths hold clues about the planet's formation and the forces that continue to shape it. By studying these materials, scientists can gain insights into the Earth's past and the dynamic processes that continue to influence its future. Studying the Challenger Deep can help us understand the processes that drive plate tectonics, volcanic activity, and even the origins of life itself. This remote and extreme environment holds many secrets, and each expedition brings us closer to unraveling the mysteries of our planet's deepest frontier. Section 5. Life in the Darkness, Adapting to the Abyss. The depths of the Mariana Trench are a testament to the incredible adaptability of life. This trench, the deepest part of the world's oceans, plunges nearly 36,000 feet below the surface, creating an environment that is both hostile and fascinating. Despite the extreme conditions, a surprising diversity of creatures call this alien world home. From the tiniest microorganisms to larger, more complex animals, life has found a way to thrive in the darkness. These organisms have evolved unique adaptations to survive in an environment devoid of sunlight, under immense pressure, and with limited food sources. The absence of light means that photosynthesis is impossible, so these creatures rely on other means to sustain themselves. One of the most striking features of many deep-sea creatures is their bioluminescence. This ability to produce light is not just for show, it serves critical functions in their survival. In the absence of sunlight, many animals have developed the ability to produce their own light, using it to attract prey, find mates, or deter predators. This self-generated light can be a beacon in the darkness, guiding creatures through the abyss. Some, like the anglerfish, dangle glowing lures in front of their mouths to entice unsuspecting prey. This adaptation is a perfect example of how life in the deep sea has evolved to turn the darkness to its advantage. Other creatures have adapted to the crushing pressure by developing gelatinous bodies, which are less susceptible to the intense pressure that would crush more rigid structures. This adaptation allows them to withstand the immense weight of the water column, which can be over 1,000 times the atmospheric pressure at sea level. Many deep-sea fish have also lost their pigmentation, appearing ghostly white or translucent in the darkness. This lack of color is another adaptation to the lightless environment where camouflage and visual signals are less important. These adaptations highlight the incredible plasticity of life and its ability to thrive in even the most challenging environments. The deep sea remains one of the least explored and most mysterious places on Earth, continually surprising us with its resilient inhabitants. Section 6. Technological Marvels, Exploring the Unseen Depths. Exploring the Mariana Trench is a technological marvel, pushing the boundaries of engineering and human ingenuity. Submersibles designed to withstand the crushing pressure and navigate the pitch-black depths are feats of engineering. These underwater vehicles are equipped with an array of sensors, cameras, and robotic arms, allowing scientists to observe and collect samples from this extreme environment. Remotely operated vehicles, or ROVs, have become indispensable tools for deep-sea exploration. These tethered robots, controlled from the surface, can reach depths inaccessible to human-occupied submersibles. Equipped with high-definition cameras, powerful lights, and manipulator arms, ROVs provide a virtual window into the abyss, transmitting real-time data and imagery back to researchers. In recent years, autonomous underwater vehicles, or AUVs, have joined the ranks of deep-sea explorers. These untethered robots can follow pre-programmed routes, mapping the seafloor, collecting data, and even deploying scientific instruments. AUVs offer a glimpse into the future of deep-sea exploration, allowing for longer missions, wider coverage, and greater flexibility in exploring the ocean's depths.